Today, we're diving into one of the most extreme urban environments on the entire planet, Riyadh, Saudi Arabia. And this is a story about the invisible forces that shape a city. We're talking everything from huge planetary mechanics all the way down to the air you're breathing inside your own home. So what exactly makes this city a place of such invisible extremes? Let's find out.
Okay, let's start with a single number that really defines life in Riyadh, 29%. What is that? Well, that's the city's average annual humidity. To put it simply, we're not just talking about a dry climate. This is a state of permanent extreme dryness. And just to give you some perspective, a city like London averages around 75% humidity. See, in a place like London, the air is often naturally healthy. But in Riyadh, healthy air isn't just a given. It's something that has to be meticulously engineered.
Now, for the second extreme, this number here represents the average amount of fine particulate matter, what scientists call PM 2.5, in the air across Saudi Arabia. You can think of these as microscopic bits of dust, sand, and pollution just floating all around you.
And look at the scale of this challenge. The World Health Organization's safe guideline is just 5 micrograms per cubic meter. The air in this region is consistently more than 10 times that level. So yeah, we're dealing with two incredibly powerful, invisible extremes here.
So that brings us to the big question, right? Why? How did this city end up being defined by these two extremes, this incredible dryness and all this dust? Well, the answer is this fascinating story where planetary science, geography, and modern life all collide.
To get our first answer, we have to zoom way, way out. Forget about the desert for a second, and let's look at the entire planet. Because Riyadh's dryness actually starts with this massive, globe-spanning engine in our atmosphere.
And that engine is called the Hadley Cell. Probably the easiest way to picture it is like a giant conveyor belt in the sky. It scoops up warm, wet air from the equator and then dumps cool, dry air over the world's great deserts, which includes, you guessed it, the Arabian Peninsula. Riyadh is sitting directly under the off-ramp for all this dry air.
And this whole process is just relentlessly efficient. So you get moist air rising at the equator, it rains out all its water there, then it travels way up in the atmosphere. By the time it drifts over to Riyadh's latitude, the now dry air starts to sink. And as it falls, it gets compressed and heats up, creating this permanent high-pressure lid that literally stops clouds from forming. It's like the planet itself is just squeezing all the moisture out of the sky.
This quote really sums it up perfectly. It's like a multi-scale geophysical conspiracy. The Hadley Cell is the first part of this conspiracy, but it's not the only piece of the puzzle. So now, let's zoom in a little bit to the regional scale.
You know, having a giant atmospheric engine trying to dry you out is one thing. But Riyadh's problems get even worse because of its specific location, which acts like a second, really formidable barrier to any kind of moisture.
Just look at where Riyadh is on a map. It's deep inland, hundreds and hundreds of kilometers from any major body of water. So any moist air from the sea has this long, hot journey to get there, and it loses pretty much all of its moisture long before it ever arrives.
And if being landlocked wasn't already enough, there's another geographic barrier, something called the rain-shadow effect. This is what happens when a mountain range literally acts like a wall, stopping rain from ever getting to the other side.
And this is exactly what happens just to the west of Riyadh. You've got moisture coming in from the Red Sea, and it hits the Es-Sir Mountains. It's forced to go up, it cools down, and it dumps all its rain on those western slopes. By the time that air gets over the mountains and down towards Riyadh, it's been stripped of almost all its water, creating one of the most intense rain shadows you'll find anywhere on the planet.
So you've got a city squeezed by planetary forces and then walled off by geography. That's what creates the extreme dryness. But that same dryness, when you combine it with the desert landscape, creates the second threat, a constant, invisible blizzard of dust.
We're talking about PM 2.5. These particles are so incredibly small they're measured in micrometers. And in this region, it's a mix of natural desert dust and man-made pollution from cars, factories, and all the construction. And the crazy part is, to your naked eye, they are completely invisible.
To give you a sense of scale here, a single particle of PM 2.5 is 30 times smaller than the width of one of your hairs. And it's that microscopic size that makes it so dangerous.
The exposure levels are just relentless. Remember, the annual average here is 10 to 12 times higher than what the WHO says is safe. So this isn't just about the occasional dust storm. This is the quality of the air year-round.
And the reason for this is that the entire region is basically a major dust corridor.
You've got strong winds constantly picking up desert dust, and then the rapid growth of cities adds its own pollution to the mix. It's really a perfect storm of natural and man-made particles.
Okay, now we bring our story to its final and maybe most personal scale. We've gone from the planet to the region to the city, and now we're going to go inside the home, where you might think you're safe, but that's where this story takes a really surprising turn.
So, we build these sealed, air-conditioned homes to escape the brutal heat outside, right? But what if solving that one problem has actually created another, much more insidious one?
Okay, think about this for a second. In normal air, dust particles absorb a little moisture, they get heavy, and they fall to the ground. But powerful air conditioning does what? It dries out the indoor air, sometimes all the way down to 15% humidity. In that bone-dry environment, those tiny PM2.5 particles, they stay light, and they just float for hours, constantly being recirculated through the air you're breathing.
And the health consequences of this are severe. Because these particles are so small, they completely bypass your body's natural defenses. They can travel deep, deep into your lungs, right into those delicate little sacs where oxygen enters your blood. And this can trigger inflammation, it can impair your lung function, and over time, it can increase the risk of really serious diseases.
So the key takeaway here is this. PM2.5 isn't just some annoyance you have to wipe off a table. It is a persistent, microscopic health hazard. The very technology that we've engineered to keep us comfortable might actually be making us sick. And all of this leaves us with one final, vital question. Riyadh is an engineering marvel, right? A city that is thriving in one of the world's harshest climates. But that very same engineering has created new invisible challenges. So the next great test isn't just engineering our buildings, it's engineering the very air we breathe to make it truly safe.
To defeat PM 2.5 in desert climates, isolated devices aren't enough. You need a stable indoor environment of 45 to 55% optimal humidity. Discover the world's first integrated humidity management system. Visit coolpexarabia.com.